Hello and welcome back to MA211. Let's go ahead and do some examples of solving ODEs using integrating factors. So this first order ODE that we see here, this is already in standard form. Let's get my tablet back. All right. So the first thing we should do, we should calculate our integrating factor. Mu of x is going to be e to the integral of positive 2x dx, so the positive 2x is coming from right there, and that's obviously e to the x squared. So that's step 1. Step 2, I should multiply everything by my integrating factor and get e to the x squared y prime plus 2x e to the x squared y equals x e to the x squared. And now this left-hand side, if you check, that's really the derivative of e to the x squared times y. You should always check and make sure that that's correct, and this time it is. If it's not correct, then you messed up calculating the integrating factor. Go back and recalculate it. And on the left-hand side, you still have x e to the x squared. Step 3, you should integrate both sides. If you integrate the left-hand side, you get e to the x squared y. And on the right-hand side, you'll get 1/2 e to the x squared plus a constant. Alright, and now step 4, you should go ahead and just solve for y. If you do that, you'll get y is 1/2 plus c e to the negative x squared. And that's it. So you should be trying these problems before you watch me solve them, so you get an idea of what's going on here. Number 2 is only slightly more difficult. It's not in standard form, so the first thing you should do is put it in standard form. If you don't put it in standard form first, your calculation of the integrating factor will be all wrong. So in standard form, you get dy dx plus 2 over x y should be 3 over x. So step 1, my integrating factor, mu of x, is e to the integral of positive 2 over x dx, and that's e to the 2 natural log of x. And now be careful. You can simplify this, but you don't get 2x. Okay, what you get, this is e to the natural log of x squared, and so that is x squared. So your integrating factor here is x squared. 2, you should multiply everything by your integrating factor. You'll get x squared dy dx plus 2xy should be 3x. On the left-hand side, if you check, this is really the derivative of x squared dy dx. And on the right-hand side, you have 3x. So step 3, now you should integrate both sides, and you'll get x squared dy dx. Oops, this left-hand side was not, that's not a dy dx there, that's just y. So you'll have x squared times y needs to be equal to 3 over 2 x squared plus a constant. And so step 4, you solve for y. Now you see that y is equal to 3/2 plus c x to the minus 2. And that's it. So let's try another one. This one again is not in the standard form. To put it in the standard form, we should write it like this: y prime minus 2y equals x squared plus 5. So your integrating factor mu is going to be e to the integral of negative 2 dx. So that's going to be e to the negative 2x. Multiply by the integrating factor, you will get e to the minus 2x y prime minus 2 e to the minus 2x y should be e to the minus 2x x squared plus 5 e to the minus 2x. Alright, oops. Now that left-hand side, if you check, that really is e to the minus 2x times y, its derivative. That should be e to the minus 2x, x squared, plus 5 e to the minus 2x. And now step 3, you get to integrate. Okay? Now this integration is not difficult, but you do need to remember how to do it, and it's a little bit long, so let me get a new piece of paper out here. So what you want is the integral of, let's check again, e to the minus 2x, x squared, and you want the integral of something else, 5e to the minus 2x. So that one's easy. And this one you need to remember to do. This is just integration by parts. And you need to know how to do that for this course, so review if it's not clear to you how to do that. So let's see, this second integral, the first integral, this is the one I want to differentiate, so that's u. This is the one I'd like to integrate, so that's dv. So what do we get here? We'll get u times v, so x squared, and the integral of e to the minus 2x is negative 1/2 e to the minus 2x. Alright, now you have minus the integral of negative 1/2 e to the minus 2x times the derivative of this one, which is 2x. And this integral, this one, the last integral, is easy to calculate. I'll just leave that hanging down here. So this will be plus negative 5 over 2 e to the minus 2x. So that one's no problem. So what do we get here? If I simplify this, I get negative x squared over 2 e to the minus 2x. I'll have plus an integral of x e to the minus 2x, and then I'll have plus or minus 5/2 e to the minus 2x. Alright, we'll keep going. This integral, again, I'll do by parts. This will be my u that I want to differentiate. This will be my dv that I want to integrate. So what do we get? Negative x squared over 2 e to the minus 2x plus, here we'll have u times v, so I'll have a negative 1/2 e to the negative 2x again, times x, minus, and we'll have the integral of negative 1/2 e to the minus 2x times the derivative of x, which is just 1. So that's dx, and you'll have minus 5 over 2 e to the minus 2x. So let's see. This thing really likes to rotate. So we'll end up with negative x squared over 2 e to the minus 2x minus 1/2 e to the minus 2x times x. And now I need to calculate this integral, so this will turn into a minus 1/4 e to the minus 2x. And you'll have a minus 5/2 e to the minus 2x. So what do we end up with in the end? We'll end up with negative x squared over 2 e to the minus 2x minus 1/2 e to the minus 2x times x. And let me see, that'll be minus 11 over 4 e to the minus 2x. Alright, so we've got that result. Let's go back to the problem we were working on. If I integrate everything, I'll get e to the minus 2x y should be equal to, and on the right hand side it's negative x squared over 2 e to the minus 2x, and the next term is negative 1/2, or negative x over 2 e to the minus 2x, and you'll have a minus 11 over 4. E to the minus 2x, and you'll still have the constant of integration. Good. And now we just need to solve. So for y is going to be equal to, you'll have a negative x squared over 2 minus x over 2. You'll have minus 11 over 4 and plus c e to the 2x. And that's it. Alright, so let's try one more. This one again, number 4, not in the standard form, so I should put it in the standard form. dy dx plus, let me see, if I divide by x, I'll get 3 plus 1 over x, y. That should be 1 over x e to the minus 3x. Okay, we'll again calculate the integrating factor. Mu is e to the integral of 3 plus 1 over x dx, so that'll be e to the 3x plus natural log x. That's e to the 3x times e to the ln x, and that's x e to the 3x. So there's your integrating factor. 2, multiply everything by the integrating factor. Don't try to skip this step, because you try to skip this step and do too many things at a time, and people normally forget to multiply the integrating factor by the right hand side or something like that, and everything gets messed up. So let's see, you go ahead and multiply the right hand side by the integrating factor. You'll get x e to the 3x dy dx plus 3 plus 1 over x times x e to the 3x y. That should be equal to, on the right hand side, if you check, you get just 1. And on the left hand side, if we did everything correctly, then you have the derivative of y times x e to the 3x prime. That needs to be 1. So 3, we'll go ahead and integrate. So y x e to the 3x needs to be x plus a constant. And then we'll solve for y. So y needs to be, I'll say, x plus a constant over x e to the 3x. And then that's it. You're done. So integrating factors are really quite straightforward. Sometimes the integration requires some integration by parts to get things done, or some other kind of trick. And you have to remember to get the ODE in the standard form first. And I see people always forgetting to take the sign here into account. So don't forget to do that. But otherwise, should be no problem.